Hi everyone, today we are going to present to you guys our semester project, which was heart rate variability measurement system. Starting off with the background and motivation for this project is that the human heart, the beats of human heart, it varies from person to person and it does not beat at perfectly equal intervals. And this variability between these intervals, specifically RR intervals, it's called heart rate variability. And these are the thresholds mentioned, like for low HRV, normal HRV, and high HRV, which will present different symptoms according to that person. The main objectives for our project was to design an analog circuit for the heartbeat signal acquisition without using microcontrollers, and then to amplify and filter the ECG signal and then obtain a waveform for HRV analysis. Specifically, the peaks would be enough for because HRV is basically the measurement of intervals between R and R interval. So we designed the circuit accordingly. The components that we used were an ECG module, an AD8232, an op-amp, TS084 for filtration, electrode cables, and ECG electrodes, and some passive components, resistors and capacitors, and power supply, and to display our result, and oscilloscope. All of the components, they are readily available in the market. As from where we got it from Hall Road, Lahore. This shop had the module. We got the IC from this shop, and all the passive components we bought from here. The assembly of the components on the breadboard was done according to the circuit diagram, and then the components were assembled on the breadboard. As you can see, there is the ECG module, there are some resistors, pull down and pull up resistors, and IC, and a 3.3 volt to 5 volt voltage regulator for the ECG module. And next it was tested in the lab. The electrodes were placed according to these connections. 5 volts of... Now we have placed the electrodes on our body, and this is for the initial testing. This is our project on breadboard. And for the initial testing, we are doing it on oscilloscope, but unfortunately we're not getting any result for now. So hopefully with a little more modifications, maybe we'll get it. Power supply was given to the circuit according to the connections on the breadboard, and the oscilloscope wire was also connected to display the output on the oscilloscope. As you can see, the electrodes were already attached. The main part is that you are getting the peaks that you needed for your HRV analysis when the electrodes are placed. But in order to truly test your circuit, whether it is working or not, what you'll have to do is that you can take off the electrodes from the skin, and then it will show you this kind of distorted. As soon as you connect those electrodes again to your skin, the peaks will show. In this way you can do your HRV analysis. As I already told you, that HRV analysis is between R and R intervals, so those intervals are being shown on the oscilloscope. Then next what you'll have to do is you can press on the cursor button on the oscilloscope, and then find out the time difference which will be shown on the oscilloscope for each R and R interval. And in this way we got about like 4 to 5 time intervals, and then we calculated them using these formulas, and then it will give you a kind of general, not for clinical purposes of course, but like from educational point of view, general HRV will be given by using this formula of root mean square of successive differences. This is an example of the calculations that we did. We got 5 time intervals, RR time intervals, and these were the calculations using the above formula, and the total came out to be 44.1 milliseconds, which was within the normal range, and the normal range was about 20 to 100 milliseconds. Again, this project is only for educational purposes and not for any clinical proper diagnosis. For final submission, the project, it was converted onto the Vero board and soldered, and this was our semester project for our electronics course without using any kind of microcontrollers. So hope you found it helpful.